Hello, everyone. We are Chen Wei Hu and Kenneth Lin from Singapore. We are extremely honored to be here, and we are presenting our research project, exploring constraints on dialogic interactions in immersive learning environments arising from COVID-19 protocols. In such COVID-stricken era, everyone is affected, particularly teachers and students who have to interact on a daily basis. Hence, we want to find out what would happen to young Singaporean students when a different learning mode, i.e. immersive learning, is adopted. Hence, we turn our focus to decimal learning by primary school students. An emerging pedagogy called Embodied Cognition has gained traction, which holds that knowledge can be effectively gained through one's bodily actions. So what if we apply embodied cognition to the field of decimal learning? This means that the students can physically move around the decimal point to visualize the decimal number. So now the question is, how might we create an environment where students can perform such embodied cognition on decimal learning? So we came up with the idea of using Minecraft Education Edition, henceforth abbreviated as MEE, an immersive learning platform to build the desired environment. Usually, for teaching and learning to take place on such immersive learning platforms, teachers and students are co-located, and face-to-face help is readily available to help students navigate the virtual environment. However, the onset of COVID-19 around the world means that such help cannot be physically rendered. Therefore, we have to use remote learning platforms such as Zoom to mediate the decimal learning on immersive learning platforms. But existing literature focuses more on how immersive learning platforms is used in physical classrooms. So in this case, what if physical classrooms are replaced by Zoom? So our research question is this: how is dialogic interaction on decimal learning in immersive learning environments constrained in contexts where participants are not co-located and hence need to be mediated by remote learning platforms? So how do we conduct our research to investigate this question? To design the learning activities, we studied the original MEE design of decimal dungeons and created an adapted virtual world, Decimal Forest. Specifically, we focused on two learning objectives: decimal point manipulation and decimal comparison. For the first learning activity, decimal point manipulation, this is the original MEE decimal program. While it attempted to teach decimals, it was inconvenient to move the decimal point, and there was not enough comparison between the decimals to understand decimal manipulation. So in the adapted activity of ours, the students can easily manipulate the decimal point through moving the buttons. Repeated comparisons such as 2.31 and 23.1 also help them realize that by moving the decimal point to the right, they can increase the number by 10 times. For the second activity, decimal point comparison, this is the original MEE design. As you can see, the juxtaposition of decimal numbers is not clear enough. Students might compare better if the decimal points are overlaid on each other. So in the adapted activity, the students can compare the two numbers by looking at them in front. By physically aligning the numbers, they are learning via embodied cognition. So in the end, this is the Minecraft environment for the first learning activity. And this is the Minecraft environment for the second activity. So within the environment, how do we analyze the dialogic interactions of the participants? This paper's overall theoretical framework is the conversational framework developed by Professor Laurillard. The framework states that in an effective learning process, the dialogic interactions between the teachers and the students on the media consist of four essential phases. In the first phase, discursive phase, the teacher introduces a topic to the student. In the second phase, adaptive phase, the teacher perceives the learning difficulties experienced by the student and therefore adapts his way of explanation. In the third phase, interactive phase, the student interacts with the environment to achieve goals. And in the last phase, reflective phase, the student has generally grasped the concept and the teacher seeks to revise the concept with the students. This methodology is suitable for studying our learning activities since they are about a specific mathematical topic, which is decimals. Further, Laurillard advocated an individualized approach, which applies to our case since our research adopts a one-to-one tutorial approach. Additionally, Laurillard's framework regards the technological media as the center of dialogic interactions. This applies to our research where learning activities are mediated by both virtual learning platform MEE and video conferencing platform Zoom. So moving on to results analysis, what are the constraints on dialogic interactions that we identified? In the first column, R represents the researcher, A and N represent the students. The second column records the utterances from the dialogic interaction, and the third column records the coding of the utterances, whose patterns are then analyzed by Laurillard's framework. There are many cases we identified where students said "what" or "sorry" because they could not hear the teacher due to poor Zoom connections. However, the teacher does not know whether such confusion derives from conceptual difficulties in understanding the theory or simply connection issues. When the teacher explains to the student again, the student doubted herself because she thought that she got the decimal number wrong. In this sense, the poor connections cause the dialogic interactions to regress to the adaptive phase, even though the students should have proceeded to the reflective phase. Dialogic interactions are also constrained by disorientation. It is evident that after student A has uttered "to the back," the teacher wanted to clarify whether she meant to the left or to the right due to the ambiguity of the directional word. So as early as the discursive phase, the ambiguous directional words can prolong the discursive phases, where the teacher and the students try to understand each other. According to Laurillard, confusion during such discursive phase can disrupt the whole learning process. Such disorientation also happened to student N. Here, the student is trying to locate a particular button by saying "at the back." The student has answered correctly actually. However, because of Zoom, the ambiguity of the word "back" still left room for interpretation. Does she mean all the way behind or on the other side of the room? So the teacher sought to clarify the directional word. However, student N mistook the teacher's further questioning as indicating that her answer was wrong. So she switched her answer from "at the back," which is correct, to "after two," which is wrong. So if these interactions had occurred in a physical face-to-face environment, the student and teacher could directly pinpoint the location of the objects they were referring to, and they could have moved past such adaptive phase to the interactive phase or even the reflective phase. However, the difficulty of navigation prolongs such adaptive phase, which again disrupts the whole learning process. To conclude, we identified two difficulties: miscommunication and disorientation. This can prolong the discursive and adaptive phases, thereby disrupting the whole learning process and cause it to regress from the reflective phase to the discursive or adaptive phase. What are some of the reasons for such constraints? Firstly, for the conventional CO approach, the interactions are physically co-located and are able to capture each other's full expressions and body gestures, as illustrated here. In this sense, neither misunderstandings due to connection issues nor disorientation will occur, since real-life interactions are straightforward and less prone to transmission issues. Our research, on the other hand, suggests that verbal cues and physical gestures transmitted via Zoom video conferencing are likely to engender cognitive dissonance due to connection issues and inversion of images, thereby causing the dialogic interactions to stagnate or at the adaptive or even disruptive phases. Secondly, in the face-to-face CO approach, real-life bodily movements are effectively separated from the movements of the avatar in the immersive learning environment, which means that the students can distinctly distinguish the real and virtual world and do not mix up the two. However, Zoom-based immersive learning activities are characterized by an amalgamation of incomplete real-life physical movements and virtual avatar movements. In this sense, the incomplete error-prone physical movements of talking heads in the Zoom video frames might interfere with the egocentric view of a single avatar, thereby disrupting the optimal experience of the CO approach. This research seeks to fill the gap in the current literature by investigating the intersection between different forms of educational media, i.e. virtual learning platforms through MEE and distance learning platform Zoom. Given scarce resources, however, this research is characterized by several areas of improvement and future directions. Firstly, the frequency and duration of the learning sessions with the primary school students are generally limited. And as such, the intervention's effect on the students' mathematical learning may not be that substantial. Secondly, with regards to the application of Laurillard's conversational framework, it is notable that the teaching and learning activities designed in this study does not incorporate or allow room for the interactive phase. Had the students been given more agency and allowed to explore the affordances in the virtual environment, they may get more familiar with the MEE environment and hence decimal concepts through embodied cognition. This is the end of our research. Thank you very much for your listening.